Using aluminum conductors for service feeders in parallel presents several challenges and considerations. Aluminum has a higher resistivity than copper, resulting in increased power loss and voltage drop. This means that for the same current carrying capacity, an aluminum conductor will experience a greater voltage drop and generate more heat than a copper conductor of the same size. This increased power loss can lead to higher energy costs over the lifespan of the installation. Aluminum is also prone to creep relaxation. Creep relaxation is a phenomenon where the conductor material slowly deforms under constant stress, such as the pressure exerted by a connector. Over time, this can cause the conductor to stretch and loosen within the connection, increasing the contact resistance. Increased contact resistance leads to overheating and potential connection failures. To mitigate these challenges, several measures should be taken. Firstly, proper torquing of connections is crucial. Regularly inspecting and torquing the connections to the manufacturer's specifications is essential to maintain proper contact resistance and prevent overheating. However, it is worth noting that repeated torquing can damage the threads of the connector, so care must be taken to avoid over-torquing. Secondly, using connectors specifically designed for aluminum conductors is essential. These connectors are typically made of aluminum alloys that are compatible with aluminum conductors and designed to provide a stable, low-resistance connection. They often feature serrations or other surface treatments to improve contact and prevent oxidation. Thirdly, temperature monitoring can help identify potential issues early on. Regularly monitoring the temperature of connections using thermal imaging or other methods can help detect overheating, which is an indication of a loose or corroded connection. If overheating is detected, the connection should be inspected and retorqued or replaced as necessary. When considering the cost, aluminum is generally cheaper than copper, but the need for additional inspection and maintenance can offset some of the savings. The increased power loss due to aluminum's higher resistivity may also result in higher energy costs over the lifespan of the installation. There are additional considerations as well. Obtaining cooperation from the power company to coordinate yearly power interruptions for inspection can be challenging. Power companies typically have strict procedures for disconnecting and reconnecting power, and it may be difficult to schedule yearly interruptions that are convenient for both the customer and the power company. Some insurance companies may require more stringent inspection and maintenance protocols for aluminum conductors. This is because aluminum conductors are perceived to be more prone to failure than copper conductors, and insurance companies want to minimize their risk. In conclusion, while using aluminum conductors for service feeders in parallel is technically feasible, it requires careful attention to mitigation measures to ensure long-term reliability. The added costs of inspection, maintenance, and potential power loss may outweigh the cost savings compared to copper conductors. It is advisable to thoroughly weigh the pros and cons and consider the specific project requirements before making a decision. In many cases, copper conductors may still be the preferred choice for service feeders due to their better electrical properties and low maintenance requirements. When considering the use of aluminum conductors in electrical systems, it's important to be aware of the relevant standards and codes. The National Electrical Code, or NEC, provides detailed requirements for the installation and use of aluminum conductors, including ampacity ratings, termination methods, and grounding requirements. Following these requirements is essential to ensure the safety and reliability of the electrical system. Aluminum conductors are commonly used in various electrical applications, particularly in overhead power transmission lines. The lighter weight of aluminum compared to copper makes it advantageous for long spans between support towers. However, for service feeders and branch circuits within buildings, copper is often preferred due to its low resistivity and greater resistance to corrosion. When using aluminum conductors, it is essential to use proper termination techniques to prevent oxidation and loosening of connections. Aluminum oxide is a poor conductor of electricity and can lead to increased resistance and overheating. Using antioxidant compounds and properly rated connectors is crucial for ensuring a reliable connection. In addition to the NEC, other industry standards and guidelines provide recommendations for the proper installation and maintenance of aluminum conductors. These resources can help ensure that the electrical system is installed and maintained in accordance with best practices. Consider the specific application when deciding whether to use aluminum or copper conductors. Factors such as the length of the run, the ampacity requirements, and the environmental conditions should be taken into account. In some cases, aluminum may be a more cost-effective option, while in others copper may be the better choice. Proper grounding is essential for all electrical systems, but it is particularly important when using aluminum conductors. Aluminum is more susceptible to corrosion than copper, and a properly grounded system can help prevent corrosion and ensure the safety of the electrical system. Regularly inspect the grounding connections to ensure that they are tight and free of corrosion. Consider the potential for galvanic corrosion when using aluminum conductors in conjunction with other metals. Galvanic corrosion can occur when two dissimilar metals are in contact in the presence of an electrolyte such as water or moisture. The aluminum will corrode preferentially, which can lead to failure of the connection. To prevent galvanic corrosion, use compatible metals or isolate the aluminum from other metals with a non-conductive barrier. When using aluminum conductors in wet or corrosive environments, take extra precautions to protect the conductors from corrosion. Use corrosion-resistant connectors and coatings and ensure that the conductors are properly sealed to prevent moisture from entering the connections. Temperature dating of aluminum conductors may be necessary in certain applications. The ampacity of a conductor is the maximum current that it can carry safely without overheating. The ampacity of aluminum conductors is typically lower than that of copper conductors of the same size. In addition, the ampacity of a conductor may need to be derated if it is installed in a hot environment or if it is bundled with other conductors. Consult the NEC for guidance on temperature derating of conductors. Consider the long-term maintenance requirements when deciding whether to use aluminum or copper conductors. Aluminum conductors require more frequent inspection and maintenance than copper conductors due to their susceptibility to creep, relaxation, and corrosion. Factor in the cost of these maintenance activities when comparing the total cost of ownership of aluminum and copper conductors. The use of aluminum conductors in service feeders can be a viable option, but it requires careful planning and execution. By following the recommendations outlined above, you can minimize the risks associated with aluminum conductors and ensure the safety and reliability of the electrical system. Remember that electrical work should always be performed by qualified professionals who are familiar with the relevant codes and standards. Improper installation or maintenance of electrical systems can lead to serious injury or property damage. Before making a decision, consult with a qualified electrical engineer or contractor to determine the best solution for your specific needs. They can help you evaluate the pros and cons of aluminum and copper conductors and recommend the most appropriate option for your application. Additionally, consider the impact of using aluminum versus copper and the overall sustainability of the project. Aluminum is more abundant than copper, but the production of aluminum is more energy intensive. Evaluate the environmental footprint of each material and factor that into your decision-making process. When working with aluminum conductors, always use the proper tools and equipment. Use torque wrenches to ensure that connections are properly tightened. Use wire strippers designed for aluminum conductors to avoid nicking or damaging the conductors. Use antioxidant compounds to prevent oxidation of the connections. Consider the use of compression connectors when terminating aluminum conductors. Compression connectors provide a more reliable connection than screw-type connectors, especially in applications where vibration or thermal cycling is present. Compression connectors require the use of a special crimping tool, but the investment is often worthwhile in terms of improved reliability. When installing aluminum conductors in conduit, be sure to use the correct size conduit. Aluminum conductors are larger than copper conductors for the same ampacity, so a larger conduit may be required. Overfilling conduit can make it difficult to pull the conductors and can also lead to overheating. Consider the use of aluminum built-in wire with a compact strand construction. Compact strand conductors have a smaller diameter than conventional stranded conductors, which can make them easier to install and terminate. Compact strand conductors also have a higher ampacity than conventional stranded conductors, which can allow you to use a smaller conductor size. When splicing aluminum conductors, use a splice kit that is specifically designed for aluminum conductors. These kits typically include antioxidant compound, insulating tape, and a crimp connector. Follow the manufacturer's instructions carefully when installing the splice kit. Consider the use of aluminum lugs and terminals that are plated with tin or nickel. These platings help to prevent corrosion and improve the conductivity of the connection. Be sure to use lugs and terminals that are rated for the specific size and type of aluminum conductor being used. When installing aluminum conductors in underground applications, be sure to use direct burial rated cable. Direct burial cable is designed to withstand the harsh conditions of underground environments. It is typically made with a moisture-resistant insulation and a corrosion-resistant jacket. Consider the use of ground fault circuit interrupters, or GFCIs, on circuits that serve outdoor equipment or wet locations. GFCIs can help to protect people from electric shock in the event of a ground fault. Aluminum is a good conductor of electricity, but it is also a good conductor of heat. When installing aluminum conductors in areas where there is a risk of fire, be sure to use fire-resistant insulation and jacketing. Fire-resistant materials can help to slow the spread of fire and protect the conductors from damage. Consider the use of arc fault circuit interrupters, or SIs, on circuits that serve bedrooms and other living areas. A SIs can help to prevent fires caused by arcing faults. Arcing faults are a common cause of electrical fires, and a SIs can help to detect and interrupt these faults before they can start a fire. When working with aluminum conductors, always wear appropriate personal protective equipment, or PPE. PPE can help to protect you from electric shock, burns, and other injuries. PPE should include safety glasses, gloves, and appropriate clothing. Always de-energize the circuit before working on it. Verify that the circuit is de-energized using a voltage tester. Tighten and lock out the circuit breaker to prevent it from being accidentally re-energized. If you are not comfortable working with electrical systems, hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. Remember, safety is always the top priority. Take the time to plan the work carefully and follow all safety precautions. By doing so, you can minimize the risk of accidents and ensure the safety of yourself and others.